Projects. In this video, we are going to explain about a project titled Insulin and Diabetes Prediction. Diabetes is a prevalent chronic disease that affects the million worldwide. In this project, we harness the power of machine learning algorithm to predict the diabetes. We aim to identify the most effective approach for the accurate and the early detection of diabetes. Our study involves data visualization, feature selection, and the model building on the diverse data set to evaluate each algorithm performance rigorously. And the objective of this project is to perform a comprehensive comparative study of 6 powerful machine learning algorithms like of KNN, logistic regression, SVM, decision tree, random forest, and the gradient boosting. Our aim to develop accurate and efficient predictive model that can identify the individuals at risk of diabetes based on the relevant health indicators. Through the rigorous evaluation and the feature selection technique, we seek to determine the most suitable algorithm for the early detection and the accurate classification of diabetes. This study holds the significant potential to empower the healthcare practitioners and the individuals by providing the personalized insight into the diabetes risk. The requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel IP and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the library. In this, essential Python libraries like Pandas, NumPy, sklearn, matplotlib, Cbun, Flask are imported to enable the data manipulation, visualization, and the machine learning model building. And the second one is importing the dataset. The dataset containing the features such as number of pregnancies, glucose, blood pressure, insulin, BMI, and of many more. This dataset serves as a basis for the training and evaluating the machine learning model. And the third step is data visualization. Data visualization techniques such as bar plots, histograms, scatter plots, and correlation matrices are employed to gain the insight into the distribution and the relationship between the different features. And the next one is model building. Here, various machine learning models are built. The first one is KNN. It stands for K nearest neighbor. Is a simple and the initiative supervised learning algorithm used for the classification and the regression task. In this project, KNN is applied to predict the diabetes status based on the relevant feature. The algorithm calculates the distance between the input data and all the points in the training set to identify the K nearest neighbor. The class label of the input data point is then determined based on the majority of these neighbors. And the second one is logistic regression. It is a linear model used for the binary classification task, making it suitable for predicting the binary outcome like diabetes status in this project. The algorithm estimates the probability that an instance belongs to a particular class using the logistic function. And its probability is above a threshold, the instance is classified into the one class, otherwise it belongs to the other class. And the next step is SVM. SVM is support vector mission, powerful, and in this project, SVM is employed for diabetes prediction. It aims to find the optimal hyperplane that best separates the data points of the different diabetes class. SVM can handle both the linear and the non-linear classification problem through the use of kernel function like of RBF kernel. And the next one is decision tree. Decision tree is a tree-based supervised learning algorithm used for the classification task. In this project, it is utilized to predict the diabetes status based on the relevant feature. Decision tree creates a tree-like structure where each internal node represents a decision based on the feature, and each leaf node represents the class label. The tree is constructed by recursively partitioning the data into the subsets based on the most informative features at each level. And the next one is random forest. Random forest is an ensemble learning method that combines the multiple decision trees during the training process. In this project, the random forest is applied for the diabetes prediction, where each tree is trained on the randomly selected subset of the training data and the features known as baggage. The final predictions is made by combining the prediction of all the individual trees through the voting for the classification task. Random forests reduce the overfitting, increases the prediction accuracy, and handle the large data set with the high dimensionality. It robust against the outliers and missing values, making it a versatile algorithm suitable for the various classification tasks. And the next one is gradient boosting. It is another ensemble learning algorithm used for the classification task. In this project, gradient boosting is employed for the diabetes prediction. Its sequentiality trains a series of weak learners and assigns the high weight to the misclassified instance in each iteration. The subsequent weak learners focus more on the misclassified data point, gradually improving the overall performance of the model. Gradient boosting is most effective in the handling the complex data structures, tend to have the high accuracy and handle both the regression and the classification task. It is robust and prone to overfitting, make it a powerful algorithm for the real-world problem. And the next step is training the model. The algorithms are trained using the pre-processed data to learn the underlying pattern and the relationship between the feature and the diabetes outcome. And the next step is user gives the input. A Flash web application is developed to allow the user to input the data for the diabetes prediction. Users provide the input value for the relevant features through a user-friendly interface. And the next step is the pre-processing for prediction. The user input is pre-processed to ensure it aligns with the format used during the training. Pre-processing includes handling the missing value, scaling the other necessary data transformations. And the next step is prediction using the trained model. The pre-processed input is fed into the trained model where each algorithm predicts the likelihood of the user having the diabetes based on the input data. And the next one is displaying the final outcome. The prediction from all the algorithms are collected and displayed to the user. This final outcome provides the insight into the probability of the user having the diabetes, enabling them to make the informed decision based on the prediction. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The dataset folder containing of diabetes dataset, and the static folder containing of the folders like CSS, images, JavaScript, web fonts within it, and the template folder containing of home, index, results, sign-in and sign-up pages within it, and the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And this is an IPYNB file which likely contain the information as the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the models are the pickle file which contain the information of algorithm and loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data or performing the specific operation. And signup.db is a file appeared to be the database used to store the user information. And for execution of the project, we need to copy this code folder path and then open the Anaconda prompt. Here first we need to change the location of the disk to F because our code folder is present in fdisk. Then write a command that is cd space and paste this code folder path. And click on enter button. By this it will change the current directory to the code folder path. And then write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime error for any logical issue or the syntax error. And then click on enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this local link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. And then click on the enter button, and here we can see the sign up button. Click on the sign up button. Here we can see the necessary details that are need to be filled to create an account, but my account is already created, that's why I'm using the sign in button. Here it redirected to the sign in page containing of username and password as of admin. And then click on the sign in button. Here it will redirect it to the index file containing of the details like of we need to be entered. And I'm entering the details of number of pregnancies as of 6, and the glucose level is of 149, and the blood pressure is of 76, and the skin thickness is of 34, and the BMI is of 34, and the pedigree is of 0.678, and the age is of 50. And then click on the submit button. Here it will redirect it to the result page, and it giving and result as a sentence of you have a chance of having the diabetes and the insulin required is of 150 ml. And click on the back button and the refresh button. Here we can enter the other details too. I'm entering the details as of number of pregnancies as of 6, and the glucose level is of 149, and the blood pressure is of 78, and the skin thickness is of 32, and the BMI is of 27, and the pedigree is of 0.987, and the age is of 23. And then click on the submit button. Here it will redirect it to this page and giving a message you are safe and you don't have a disease. In this way we can predict the diabetes presence and absence and giving the insulin level too. And in conclusion, our rigorous comparative analysis of various machine learning algorithms on the insulin prediction and the diabetes classification has yielded the valuable insight. Through the meticulous evaluation and the performance metrics, we have identified the most effective approach for the accurate insulin prediction and the diabetes classification. These findings hold the great promise for the healthcare practitioners, enabling them to make the informed decision and the implemented target intervention in the diabetes management. By leveraging the potential of the machine learning in healthcare, we pave the way for improved patient outcome, enhanced medical decision making, and advancement in the diabetes treatment and the prevention strategies.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.